Hello, this video is being made as a part of an assignment to computer science students at Bennett University. Now, in this video, I will be explaining about ALOHA protocols in computer networks. Now, coming to the topic, what is ALOHA? And let's get to the basics. It all comes under multiple access protocols. And what are multiple access protocols? They are used to coordinate access to the link, and nodes can regulate the transmission onto the shared broadcast channel. What am I explaining is that let's say there is a local area network, or let's say there's a network, and there are multiple nodes with a shared medium to transmit. But the problem is that whenever multiple nodes send a message at the same time, there is a problem of transmitting the proper message to the proper destination. So multiple access protocols regulate these message timings and avoid errors in the messages. Now, it is not a bare thing. The multiple access protocols are divided into three types, which are random access protocols, controlled access protocols, and channelization protocols. Now, in the image, it is very clear where ALOHA is. ALOHA is in random access protocols, and what random access protocol does is that there might be other methods where every node is assigned some timing to send a message, but now in ALOHA, since it is in random access protocols, what random access protocols does is that every node has the freedom of sending a message at any time. Now, coming to the main point of ALOHA, what ALOHA is we've seen it's a random access protocol, and it is developed for LAN networks, or local area networks, basically at the starting of 1970s. And there are two types. One is pure ALOHA and a shared ALOHA. In pure ALOHA, as we discussed, since it is a random access protocol, the data can be transmitted at any time. And once a node transmits the data to the destination node also sends an acknowledgement back to the original node. And when the acknowledgement is received by the original node, it understands that my data has successfully received at the destination. But there might be a problem where the message had a problem during the transfer. And so whenever the timeout occurs, the original node, what it actually does is that it resends the same message after a random amount of time. Why a random amount of time is that, let's say there are two senders which have sent a message at the same time, but due to the problem that both of the messages have been mismatched, or both of the messages have been mixed up. So let's say both of them actually exactly after 5 seconds send the same message, and the same problem occurs. So to avoid this and decrease the probability of the messages being mixed up, we are resending it after a random amount of time. And to decrease the complexity, we use a fixed frame size. And vulnerable time, eta, which is the efficiency, and maximum efficiency will be discussed later. Now let's look at this picture. The lines you see are the shared medium, and A, B, C, D, E, and F are the nodes. Now in pure ALOHA, you can see that there are multiple frames being sent. Initially, the frame A is sent. A frame of A is sent, node A, then B. Then notice the colors. All these nodes are in blue, and there are some parts of the frames which are in gray. The gray messages are the messages where the data is being mixed up with with other messages. So when you consider here the message sent by C and the message sent by E are being mixed up. So the ending of E and the starting of C are being mixed up. To avoid this problem in ALOHA, what we actually define is the vulnerable time. Vulnerable time is the time when we take the starting point. Let's take the message of C here for more clarity. Let's take the starting point of C message, or the frame sent by C, as T. Now, and let the time of each frame be T frame, and since it is the same, let's take it as T frame. Now from the starting point T, take the time T minus T frame and T plus T frame, and in this time there shouldn't be any message being starting, and since the message sent by E is inside the vulnerable time, it is being mixed up with some part of the message C, and since this is happening, we have defined the vulnerable time as 2 times of T frame, and the efficiency formula has been defined as G into e power minus 2G. And notice why the 2 occurs is that the 2 comes from the vulnerable time formula, which is 2 into T frame, and G is the number of nodes here. And when you differentiate the formula of the efficiency and you find out the maximum possible efficiency, you find it as 0.184, or which is 18.4%, which is pretty low in today's terms. But this is actually for the value of G equals 1 by 2 or half nodes. Now 18.4% is very less, so out of all the data you send, only 18.4% of the bandwidth can be successfully sent. This is about pure ALOHA. Now coming to slotted ALOHA, we find it is developed as an improvement for pure ALOHA. So initially came pure ALOHA, then there were some problems and slotted ALOHA was developed. Transmit data only at beginning of discrete time intervals. Now it has a similar concept of pure ALOHA, but what we have done is that all the random time is divided into discrete time slots. Now let's dive into the picture, and you can see the dotted lines in the same shared medium. And notice that all the messages are exactly inside the discrete time frames, right? And similar to the last example of pure ALOHA, the gray colors, which is the message sent by A and C, are being mixed up. But notice that since the messages start at the same beginning time, there is a very less probability that 2 messages will be mixed up or will be sent at the same time. So the vulnerable time is just T frame, and efficiency equals G times e power minus G. And since the vulnerable time doesn't have a 2 in it, and we don't have 2 in the efficiency, and calculating it by differentiating, the maximum efficiency you can achieve is a 36.8%, which is about double of what pure ALOHA achieves, and it is for G equals 1 or for one node. It is obvious because if one node transmits a message, it obviously has a maximum efficiency or 100% efficiency, and this is what slotted ALOHA achieves. Slotted ALOHA is just pure ALOHA, but actually there are some discrete time intervals which actually improves the efficiency by twice, right? Now this is the main concept of ALOHA, pure ALOHA and slotted ALOHA. And now I'd like to talk about the references. The images which you've seen have been collected from Google Images, and the concepts you've seen are from various online sources and from the curriculum of Bennett University. And finally, thank you for watching the video.